Hi, hello friends. Welcome to Indian Tech Guru for you. In this video, let us learn how to implement distance vector routing using packet tracer software. So it is a simulation where we can implement the distance vector routing. So for that, first of all, let us create three different networks, and each network shall contain two personal computers, one switch as well as one router, and we will be connecting these three different networks using routers, and then using the distance vector routing we will be transmitting the packets from one particular PC to one particular PC of one particular network to another PC of other network. So for that purpose, first of all, let me click on ND devices and select two generic PCs for network 1 and another two generic PCs for network 2 and another two generic PCs for network 3. Initially, these two personal computers must be connected to a switch. So I am selecting switches and then select a particular switch for network 1, select another switch for network 2 and select another switch for network 3. Now it is time to take three routers for three different networks. Click on routers and select one router for network 1, another router for network 2 and another router for network 3. So these are the individual components we need to select. So this entire range is described as network 1, this range is described as network 2 and this range is described as network 3. Now it is time to assign the IP addresses for each and every network, personal computers as well as the router. We know that switch do not have any IP address. So switch is an intelligent device which can transfer the data from one device to another device in a particular network. So initially the routers must be configured. So here this particular router, you can observe that it is not having the serial ports. So to connect one router to another router, we must have a serial port. For that purpose, first of all, we need to make sure that serial ports are enabled. Just double click on that particular router and you need to select WIC2T, and here there are multiple switches available, there are multiple serial ports available. So that's why you need to move this particular 2-port serial network module to this area. So before moving, you need to switch on the particular device and then move the serial ports and once again switch on. Now you can observe that in the configuration tab, you can find serial 000, serial 001. Two serial ports are available. Similarly, the same thing must be applied to all the routers. So now I am configuring router 1. Double click on router 1. If you see here the config, now there are no serial ports at all. So after adding the serial ports only, it is going to display the serial ports. So click on physical, WIC2T, switch off the particular device, move the serial ports to this location and once again switch on. Now you can see in the config, so it is still booting. After the booting is completed, if you click on config, you can see serial 000, serial 001. Two serial ports are there. Similarly, do the same thing for router 2 also. WIC2T, switch off move the serial ports, switch on. So now the required serial ports are available to connect different routers. Now it is time to connect all the personal computers to switches, as well as the switch to router and one router to another router. So before that, we need to decide on the IP addresses. So for network 1, I would like to give the IP address as 192.168.1.1. Similarly for network 2, 2.1, for network 3, 2.3.1. So for that purpose, first of all, before actually giving the IP addresses, we need to connect these devices. So click on connections here, and whenever the devices are different types of devices, we need to select the copper wire. So whenever you click on here, it will show faster Ethernet. Select the faster Ethernet, and in case of switch, it will be showing 24 ports. So I will be considering the first port, fast Ethernet 0/1, to connect first personal computers to switch. Similarly for PC2 also, select the copper wire, select fast Ethernet, and select fast Ethernet 0/2, as we have already selected 0/1. Now the PCs are connected to switch. Similarly, you need to connect switch to router. So select the copper wire. Now select fast Ethernet 0/3, and then connect to router's fast Ethernet 0/0. Now first network, individual network, is successfully completed. So now we need to connect similarly the second network. Similarly for third network. Now we have successfully connected all the individual networks with copper wires. Now it is time to connect routers. So the routers connected using the serial cable, serial DTE. Here you can find the serial DTE. Select the serial DTE and select the serial 0 of first router and connect it to serial 0 of second router. Similarly for the second router, serial 0 is already connected, so select serial 01, and for the third router select 0. Now the routers are also connected. Now it is time to give the IP addresses. So for giving the IP addresses, just click on the particular router. So for the router to be connected to the switch, we need to give the IP address for fast Ethernet, as we have connected with the fast Ethernet 0/0. Select that one and give the IP address as 192.168.1.1. and if you click on the subnet mask, automatically it is going to generate the subnet mask, and the port status must be on. Enable the checkbox to make sure that the port status is on. Now you can see here it is converted into green icon. Similarly do it for router 1 as well as router 2. For router 1, fast Ethernet 0.0, IP address is 192.168.2.1, and the subnet mask is automatically generated, and make sure that the port is on. Similarly, for router 3 named as router 2, so click on config fast Ethernet 192.168.3.1. Make sure it is on. So the IP addresses for all the routers have been given which are connected to the switch. Now for clarity, you can make the labels also. So 192.168.1.1, copy the content, select another label, paste it, 2.1, select another label, and it is 3.1. Now it is time to give IP addresses for PCs. So for this particular network, the router IP is 192.168.1.1. So that's why the PCs will be starting with 1.2, 1.3 and so on. Here for simplicity we have taken only 2 personal computers. You can take as many as personal computers if you require. So just open it, click on config fast Ethernet, here IP address 192.168.1.2, subnet mask by default it will be assigned, or otherwise you can click the desktop and click on IP config to give the default gateway also. So the default gateway for this particular network is router. The router IP address is 192.168.1.1. So you need to give the default gateway also. So I have given the default gateway. So now close it. So for it is for PC 0. So now for PC 1, click on desktop, click on IP config 192.168.1.3, subnet mask by default it will be coming, and the default gateway is 192.168.1.1. Close it. So for PCs of other networks, click on desktop, IP config 192.168.2.2 in the second network, second PC, and the subnet mask by default it will be coming, and the default gateway is 2.1. So for the next PC, I am copying the content. So for PC 3, click on desktop, IP config, it will be 2.3, subnet mask by default it will come, it will be 2.1, the default gateway, router's IP address. Next, the same thing for PC 4 and PC 5. Click on desktop, IP config, so it will be 3.2, and the default gateway will be 3.1. And finally for PC 5, click on desktop, IP config, it will be 3.3, and the subnet mask by default it will come and it will be 3.1. So like this you can give. If you want to give DNS server, give it as 0.0.0.0. So that's it. All PCs have been given the IP addresses. So if you want to see the IP address that is given to a particular PC, so just place the mouse pointer on that particular PC. So here you can see the IP address. Okay. So 192.168.1.2, 1.3, 2.2, 2.3, 3.2, 3.3. You can verify whether we have given correctly or not, and the gateway IP also you can verify whether we have given the correct gateway IP or not. Here you can see gateway IP 192.168.1.1. So for PC1 also it should be the same. For PC2 and PC3 it should be same. For PC4 and 5 it should be same. Okay, now it is verified. So all the IP addresses have been given for routers as well as PCs. Now it is time to give IP addresses for routers, the serial IP addresses for routers. So the connection between the router as well as PCs have been established, but the connection between the routers need to be established now. So open the router and select serial 0, because we have used serial 0. So and now the IP address must be given as class A address. So 10.0.0.1. Automatically the subnet mask will be given, and make the port status on. So for router 1 there are two serial connections. One is going to router 0 and another is going to router 2. So here we need to use both serial 0 as well as serial 1. Serial 0 is given to is used to connect the first router 0. So that's why it should be on the same class A network. So 10.0.0.2 I am giving, and make sure that it is on. Next, so we need to give the serial port 001 also, because it is connected to router 2. So for this I need to use other IP address 11.0.0.1 I am taking, which is connected to serial 001, and make sure that it is also on. Next, finally for router 2, so I have connected only to serial 000. So I am taking it as 11.0.0.2. So make sure that it is also port is on. Now the configuration has been completed successfully. You can see by placing the mouse pointer on it. Here you can see 10.0.0.1 serial 000. Similarly, for this router 1, serial 000 is 10.0.0.2 and serial 001 is 11.0.0.1. For router 3, that is named as router 2, the serial IP address is 11.0.0.2. So we have now configured all the IP addresses, but now we need to implement the link state routing. We need to implement the distance vector routing. For implementing distance vector routing, we need to use the RIP protocol. RIP protocol is under the routing, under the config tab. It will be available under the routing menu. So click on RIP and just give the network addresses of all the routers as well as the personal computers. So that is the Ethernet as well as from router to router. So for router 1 it is 10 point, for router 0 and router 1 it is 10.0.0.0. So 10.0.0.0 represents all the routers that are connected under 10.0.0. So we need to add it. Next add 11.0.0.0, and then we need to add the network 192.168.1.0. 1.0 represents 1.1, 1.2, 1.3 and so on. All the devices that are connected under this particular network. Similarly 2.0, similarly 3.0. We have added all the networks for router 1. Similarly, add all the networks for router 2. Click on RIP protocol. The RIP protocol is going to implement the distance vector routing automatically. So 10.0.0.0, 11.0.0.0, 192.168.0.0, sorry 1.0, 192.168.2.0, 192.168.3.0. Similarly for the final router, router 3, click on RIP protocol. So 10.0.0.0. Similarly 11.0.0.0, 192.168.1.0, 2.0 and 3.0. It means that we have interconnected all the three networks, so that the distance vector routing will be implemented successfully. Now to test whether the packet serial 0, 0, 0. So the thing is, we have not set the clock rate. So to make sure that it is working properly, we have to set the clock rate. Okay. So because we need to make sure that the content is transmitted somewhat faster. So select clock rate and give the clock rate as 64,000 for each of the router. Give the clock rate as 64,000. So here also clock rate 64,000. Here also give clock rate as 64,000. So after giving the clock rate, once again let me check. So select the data packet from PC0 to PC4. Let me check once again, PC0 to PC4. Now we can see it is successful. Okay. So if you want to make sure that step by step you want to see, then you need to move to the simulation mode. Click on simulation mode, and now you can click on auto capture or play. So now initially it is going to switch 0 and then router 0. Now you can see it is going from router 0 to router 1. From router 1 to router 2 it is moving. From router 2 to switch 2. From switch 2 to PC4. Okay. So now you have seen this successfully how the packets are transmitted. So just click on delete, and then now once again come to real time mode. But the thing is here, the data is transmitted from router 1 to router 3 via router 2. Okay, so don't confuse. Here the names are router 0, router 1, router 2, but it is router 1, router 2 and router 3. Okay, now so assume that we want to transmit the data directly from router 0 to router 2 because it is the shortest path. So in case of distance vector routing, we need to select the shortest path. So now for that purpose, so I want to establish another link from router 0 to router 2. For router 0, serial 001 is free, so select serial 001, and similarly for router 2, serial 001 is free, so select that serial 1. Now I have established another connection from router 0 to router 2. So we need to configure serial 001. So for that purpose, I am giving the IP as 12.0.0.1, and I need to set the clock rate. It is very important. Set the clock rate as 64,000 and make the serial port on. Similarly, for router 2 also, click on serial 001 and give the IP address as 12.0.0.2 and click on the clock rates as 64,000 and make sure that it is on. Now you can observe that there are two serial ports. Between router 0 to router 1, there is one serial port. Router 1 to router 2, another serial port. Router 0 to router 2, directly there is a serial port. Now let me check whether the data is transmitted directly from router 0 to router 2 instead of going through router 1. So let us once again go to simulation mode and drop a packet from PC0 to PC4 and click on auto capture and play. So it is, first of all, it is going to switch 0 and then it is going to router 0. So it is going to router 1 and it is moving to router 2. So it is following the same path. Of course, for example, click on delete. For example, assume that the particular connection between router 0 to router 1 has been broken. So I am deleting this connection. Now let me once again check now how the data is transmitted, because now there is no connection between router 0 to router 1. Click on auto capture and play. Now let me check between PC2 to PC1. So move to real time mode from PC2 to PC1. It is failed. Let us once again check the configuration for serial 000 12.0.01, 001, 12.0.02. The port is on. Now you can see data is successfully transmitted from PC4 to PC3. Yeah, actually why it is not transferring between router 0 to router 2, because so in the RIP protocol we have not added 12.0.0. So because in the RIP protocol we have not added the route 12.0.0, so it is not actually working properly. We need to add this route also. .0.0.0. Now let us see whether it is working properly or not. So I want to transfer data from PC2 to PC0 via router 2, router 0, PC2 to PC1, or PC3 to PC0. Now you can see it is successful. So sometimes even though the connection is proper, sometimes it may fail because of the time delay. So you need to try one more time. So from PC3 to PC0 it is successful. So it is going through router 1, router 2 and router 0 and making the connection successful. So whenever we add another serial DTE, we need to make sure that that particular IP address of the newly created route must be added to RIP protocol. Then it will be working properly. So in the simulation mode we can observe now. Delete all the content, and now I am going to transfer data from PC3 to PC1. Auto capture in play. PC3 to switch 1, switch 1 to router 1. If router 1 to router 0 connection is established is there, then it will be directly going to router 1 to router 0. Okay, so now if the connection is established successfully, then automatically it will be working. So once again I want to establish the previous connection, and make sure that the RIP protocol is added 12.0.0. So now it is time to check whenever I want to transfer the data from PC1 to PC4, whether it will be using the direct connection or not. So from PC0 to PC4 the connection is successful. So click on the simulation mode and see step by step. So it will be moving to switch 0, from switch 0 to router 0, from router 0 to router 2. Okay, we have successfully configured, because it is not taking the route of router 0 to router 1 and router 1 to router 2, but it is taking the shortest path, so which is nothing but the distance vector routing, implementation of distance vector routing. So with this we have successfully implemented the distance vector routing using the RIP protocol in packet tracer. So if you still have any doubts, you can clarify by making the comment. That's all for now.